Might be. Good morning. So before we start, what I'd like to do is if you guys could take a look at your stamp sheet, please. I just want to go over the plan for the week. Okay. So I want you to notice that today is the last day of notes for the chapter. So this is the last thing that we learn for chapter 2. Tomorrow we're going to do a Kahoot and the R problems. So R stands for review. So that's like the closure, basically, in CPM words. On the block day, we're going to do the team test. And the homework that night is 2 things. The AP classrooms are actually not due until the day of the test. This is always the way. They're already in there assigned. You might not know how to do all of it yet, just letting you know, but they're always due the day of the test and you can reset until then. But there's also a normal calculations review worksheet. You know how to do all of this already. So if you don't want to do that later, you could start that now. And it's basically all the things we did on Friday with the normal CDF and inverse norm. And then on Friday, we're going to do our first whiteboard FRQs. So when we have AP Classroom FRQs, and they're in your packet, if you're here, we'll do them on whiteboards, not on paper. It's just to make it more fun. And then the homework is the T problems. T problems are different from R problems. T stands for test. And there's like the first 10 are multiple choice, and then like 11, 12, and 13 are FRQ style. So it's like resembles a test. And then next week, block day is going to be our test for this chapter. I will start chapter 3 before the test. Does that all make sense? After today, I will post test topics and all of that stuff and make sure you have a note card and things. Anyway, any questions about the order of things? Okay. So the next thing I need to tell you is that today we have to do algebra. No, Mrs. Tabi, you told me this wasn't a math class. Well, I lied. It's kind of a little bit of everything class. But today we're going to do math 1 style system of equations. The problem is that it's actually, I joke, but it's more detailed than that because you're dealing with decimals and stuff that you didn't have in math 1. So I'm going to go slow on this first one. So this is how it's going to go. I'm going to do this one with you entirely slowly. Then you guys are going to do number 2 in your groups following the notes from number 1. And then we're going to come back and do the second part, which is the assessing normality part. So here we go. Congo peafowls are endangered and are being studied by researchers. The 21st percentile is 2.5389 pounds, and the 83rd percentile is 3.2027 pounds. Find the mean and standard deviation, assuming the weights follow a normal distribution. Okay, so the first thing we're going to do is draw a little baby sketch over here, just to show what we were given, make sense of the numbers. So first, draw a little baby curve. And just from our previous research, we know that, 21% of the way in. So this says the 21st percentile. So 21% of the way in-ish would be like here-ish. These do not need to be perfect. So what I'm saying is this area is 0.21, and that would be 2.5389 pounds. Any questions about that? Okay, now the other piece says the 83rd, which would be like right here-ish. Okay, but really important is that because we're talking about percentile, you note that both of those sections added together would be 83%, not just this piece, but the all cumulative 83%. And this would be 3.2027 pounds. You probably won't need to draw this picture again for these problems, but I wanted to make sure that you knew what was happening the first time we do it, just so you can figure it out. Okay, what I'm going to do is I'm going to look for a formula that I can use to make a system of equations. We only have one formula so far, and that's the z-score formula. You can get z two different ways. So we're going to do z for this first bit of information that goes with these two numbers. And if you remember, inverse norm requires an area, a mean, a standard deviation, and a tail direction. And we're going to go left because we're talking about percentiles. But what is the area for this little bit right here? Yep, 0.21. And the mean and the standard deviation are what we're solving for in the problem. However, what are the mean and standard deviation when I'm talking about z-scores specifically? 0 and 1, yes. Okay, so everybody go on the calculator, practice this. If you have the older style calculator, it's already in left. You don't need to change anything about the tail direction. Compare with your group, make sure you guys get the same thing. I got negative 0.8064. Agree? Okay, now we're going to do this again for the other piece of information they gave us. Hey, I gotta say, my estimated lines in my little normal curve sketch aren't too bad. Nice, Mrs. Talbot, nice. Did you guys get positive 0.9? Oh, is that supposed to be 2? It's supposed to be 2, right? You were just gonna let me go with that incorrect rounding? You're just gonna let me do that? Okay, now here's where the system's going to come in. So we're going to use the z formula, which is z equals x minus mean over standard deviation. Okay, and it will really help you out if you put a little x equals right here, then you can see that those are the x's, these are the z's. Okay, so we're going to have two equations. we're going to follow this format. So Z, we're going to use this first Z, negative 0.8064 equals, this is the X that goes with that one, minus the mean divided by standard deviation. Okay. 0.9542 Z equals, the X for that one is 3.2027 minus the mean divided by standard deviation. So now you have two equations, two unknowns, just like math one. I don't know about you though, I hate the fraction. Anybody else? No, you love it. You're just super excited about having a fraction in your system. I highly doubt that. I highly doubt that. Okay, but how do I get rid of the denominator? Multiply, yeah. So I'm going to multiply both sides by sigma. Okay, and then I'm going to write them one on top and one on the bottom, and I'm going to put the sigma after the number. So I'm going to skip a step here. See if you can do that. Okay, now I'm going to do elimination method, and I'm going to eliminate the mu's. But since they're both minus, I'm going to subtract the whole denominator. It's not a denominator. I'm going to subtract the whole second equation. That will make the mu's cancel out. So I'm going to go negative 0.8064 minus 0.9542. Let's subtract these. And then subtract these. And then divide both sides. I am not with the sigma. And then I'm going to take this and plug it back in. I'm going to plug it back into this top one. It doesn't matter if you do the top one or the bottom one. I just do the top one. Okay. So I'm gonna throw back to math. Did you guys know that you can sort of find a coordinate, an XY coordinate, kind of? It's not really the case. It would be if this was X and Y, but you can actually shorthand a normal distribution, factoring a capital N, and then mean, and then standard deviation. So you might see that notation. It's just for the lazy. You can write mu equals and sigma equals if you want to, but this is my lazy coming out. Okay. Now it's your turn. Okay, so if you guys are doing this on one page like I did, go ahead and write the answers for the second example at the bottom of the page, just so you can check yourself as you do the problem. You can fill in everything in between. By following example one, it's exactly the same thing, exactly the same steps, just different numbers. But I wanted to make sure you had the answer so you could check yourself as you go. And you don't need to draw the sketch again. You don't need it. Just do the algebra. Start with inverse norms, two of them.
Tomorrow? Also, it's like,
Micro and macroeconomics.
oh, really? On quiz.
I don't
So
know.
it's closer to like
Multiple choice.
40.
So basically, you'll be the definition and then what
It's really not that bad. Like, almost both guys are like 3 grades, so they're the cleanest side test. This is kind of.
Guys, real quick, did you guys not notice that there's new phone and stuff? That, yeah, I changed it again. You typed in the wrong spot. Good done. I did couldn't argue and stuff. It's fun for me to get that's when they actually have like a little bit. Man, Mrs. Dobbin, I was really thinking this morning on my breakfast, Mr. Assistant to the Equation. But this one I could. Oh, well, that's, sorry. Tell you about that. That's what I had. Figured. Yeah. Hello. Did you get it all okay?
You must have.
You guys, if you did not write the answer down, please write it down at the bottom of your page, just because I'm gonna flip this for people who are done. just make sure to check your answer. I'm not starting yet. I'm just saying. I just didn't write it in the coordinate notation because I was too lazy.
What did you do for the?
If you are hanging out waiting. What? Well,
That's scary, but.
I don't know what to tell you. This class has notes all the time. That's what we do. I could just do this for night. No.
No, we're good.
It'll be easy for me. I'll just go sit down and you guys can read the chapter.
No, we're good, yeah.
I know, I'm like, I think. No, but you always had a tunnel. And then you fail, and then you. Right, well,
We'll
that's
just stand there.
it. Sit down, and then everybody calls it.
Does it matter which one I subtract? Nope. You should get the same answer in the end.
Okay, I was just like thinking of like other.
No, because it comes out with negatives or both positives at the end. So you'll get the same answer because you're subtracting both sides.
Well, you don't take notes, you don't take notes, you don't do. But you just kind of have to correct.
It'd be a lot easier for me. I could just assign problems and sit.
No, we were talking about how much that happened about that.
And then you just watch.
Yeah, let's do it all. You want that? Well, my year didn't have that. Well, anyway.
Oh, yeah.
That's not hard.
Oh, you're asking for a space reason, not wanting to do it reason?
No.
I'm gonna go on the next page, but I think you'll be fine going on the next page.
Okay.
I don't think it's gonna show you.
Really nice. Really nice. Every other class. Because she actually wants to teach. Yeah. That's like with a lot of things, like I think this is way better than this. Stage math. But like early stage
I
math.
understand why, like,
He's like.
I get it. I get the love. Can't do it. I have to control it. They must control that. I don't know, let's, if you have, say.
One of my friends had a night and say he was on his computer. And this man walked up behind him and reached over his shoulder. Yeah.
Okay, if you do not finish this problem, you're gonna have to come back to it later.
I do know.
With all the love.
One time, in grade, in Mr. Thomas' class, to some like completely hated.
Oh my god.
The show was so funny. It happened right in front of my table. It was like,
I totally forgot that.
I felt so bad because I was laughing so much.
It's so easy to do it.
No, I just really
Okay,
hated it.
guys, last topic of the chapter is what we're gonna do, and you'll notice, did anybody try the MCQs yet? Anybody give them a go? It's okay. So there's some problems on the MCQs where they ask you if numbers are normal or not. Like numbers of numbers are normal or not. And so that's what we need to do next. We're going to take a data set, which I just made up. Pretty sure I chat GPT a bunch of numbers here, to assess it for normality. And so what we're gonna do is see if this data set pretty much fits the rules for a normal data set. And there's three different methods, but we're going to start with the simplest one. Data, sorry. It's part of my weird font that's like half cursive, half not.
Nice.
Thanks, but it's a little. Anyway, so the first way that you can assess whether a data set fits the normal curve is if you look at a graph of it and the graph shows that it's bell-shaped and symmetric. Now, to save us time, I don't need you to do this because we just don't have time for you to enter all of these numbers into L1. But what you would do is either look at a graph, make a histogram, or you would enter all the numbers into L1 and do a histogram on the calculator, which is what I did because I'm lazy. So let me just show you what I got. And you can tell me what you think. This is not what I got. Sorry. This is what I got. Okay, so we're using our analytical sides of our brain now, and we're saying, does that look normal-ish? Kinda. Okay, here's my next question. Can we rule out the fact that it's normal? Can we say that it's super skewed one way or the other? Not really. Okay, so the first thing that you do is try to rule out normal as by just looking at the graph. And we can't really rule it out in this case. It might be. We're not really sure. Not being sure happens a lot in stats. Sorry. Okay, so we're going to go down here. And we're going to say shape is inconclusive. You can't rule out a normal shape. It might be, not really sure. Okay. The next thing is that you could do is use the empirical rule. And or the fact that the max and min are about 3 standard deviations from the mean. And this is kind of the part where it gets a little bit fascinating, in my opinion. Let me zoom in for you here. Okay, now to save us time, I told you I entered all of the numbers into my calculator for L1. And so down here, I'm going to say I did one variable stats, and the mean is 15.5385. And the standard deviation is about 4.9071. Okay, so let's discuss the empirical rule. Empirical rule says 3 things. 68% of values fall within 1 standard deviation of the mean. Okay, so this is what I want you to do. Take the mean. Plus or minus 1 standard deviation. Let me say that again. The mean plus or minus 1 standard deviation on either side. Okay. I'm going to do the minus first because I like to do the low and then the high. Okay, so my low number is 10.6314. And then you write the word two. And then I'm going to scroll up and paste and change that to a plus. That's how I get my plus and minus. Do you guys all see how I did that in the calculator? I did the minus first, got this number, and then I did the plus and got this number. Okay, can you take 60 seconds in your group and count how many numbers in my data set are between these two? How many numbers in my data set are between these two numbers? Talk it out. Okay, so you counted 14, you say? Okay, so what you do is you go, okay, 14 numbers out of 20 numbers total is 0.70, which is about 68%. Oh. Okay, what am I going to do next? What's the next line of the empirical rule? 68% falls within one standard deviation of the mean. What's the next one? You could flip back if you didn't know. Anybody? Beautiful. Okay, so will you guys trust me from my numbers from earlier? So I did 2 standard deviations from the mean. That's this range here. Just for speed purposes, 19 out of 20 of the numbers, which is exactly 95%. Oh man, do you see where it's going? What's the next one? 99.7 and 3 standard deviations from the mean. Okay, so let's say you have a data set and the first one you checked came out to be like 42%. Would you need to go any further? No, you could just be like, no, not even close to 68, we're done here, don't need to move on. The only time you need to keep going is if it's sort of matchy. And you guys see the numbers that it needs to sort of matchy? 68, 95, 99.7, it's not gonna be perfect. Don't expect perfection here, it's not gonna happen. Okay. Last thing, there's a third way to check, and it's gonna be your favorite way. You're gonna forget all about this. You're gonna forget this is a thing because the other ways, graphing calculator is so much easier. Okay, go back up for just a second to that last bullet point that we did not fill in. There's something on your calculator called the normal probability plot. And you want to check to see if it's linear-ish. If it's linear-ish, then your data set is normal. It doesn't have to be perfect. Nothing in stats has to be perfect. Okay, let me show you how to make the normal probability plot. I'm going to show you on my calculator, and then we're going to write the steps down because we don't have time for you to enter all the numbers in and do everything. So, step 3, or method 3. Okay. First thing I would do would be put all the numbers into LWAT. You guys all know how to do that, correct? Everybody good on that? Okay. Then what you would do would be you would go to this thing up here called stat plot. And everything in the stat plot, you need to hit the second first. So it's second y equals. And this is what I used to do the box plot histogram earlier that I showed you guys where we looked at the shape. Okay. What you want to do, I'm going to turn this one off. I only want to do the one. You would go to the first stat plot and select the one that looks like this on the end, very right picture, and hit enter. And then pretty much everything on the calculator that we do in statistics class, you want to hit zoom 9. So look at zoom. You see how 9 says zoom stat? And that's how your normal probability plot looks for this set of data. Is that linear-ish? Yeah, so linear-ish. If you wanted to do this method to get full credit, you would have to sketch that Helio for me on your paper. Does it have to be perfect? No, but you'd have to sketch it for me if you want to use that. Okay, so let's write down the steps for the calculator real quick. Okay, so first you enter the numbers into L1. Are you at the end of the page? So second y equals, go into plot 1, turn it on and select the very right picture, and then zoom 9. And then you would have your conclusion where your graph will be roughly linear, so you could say it was normal.